Yesterday we talked about the x-axis, the y-axis, and how to label points. So if I were to ask you right now, what point would this be right here? Very good. This is point -7, 8. So that is the coordinate of that point. Good, you got the idea. Now, if I had another point, say, I don't know. Let's say this point right here. You know that's going to be 2, 17. And once I have those 2 points, I can connect them to make a line. Oopsie doopsie, lemon poopsie. No, I don't want to draw the whole thing, so I'm just going to draw little arrows on the end of them to show that that line goes on forever. Forever. Now, if I were to label these points on a graph, not a graph, on a table, I'll label all my x values and y values. I have a -7. And what's the y value?
8.
And then I have another one. I got a 2 and a 17. So this, if I gave you this, you can draw that. Now I'm going to give you something here where I'm just going to say that takes up a lot of space, and we can make up a line really like this. Instead of labeling these points, I would say this. Instead of drawing all that, write this down, and you can draw the exact same line. Can anyone explain to me how I came up with that? If you take a look at this, line right here, it goes right through the 15. So that number right there, we call that the y-intercept, because that line is intercepted by the y-axis. So very easy to come up with that number. Now the question here is, what number's in front of this x? I don't see a number, so there's a 1. Question is, where did that 1 come from? If you're not sure, let's draw another line. It's hard to tell just from one example. But now we know that that whole number right there, when you have a whole number, you know that's where the line is going to be crossing right there. Let's label these points for the fun of it. That's x is 0, y is 9. This is x is 6, y is 13. Can't see the one there. Okay, there you go. So if I were to draw an equation for this line, we know y equals something, 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 and that's a +9, so we know it's going to be +9. My question is, what is that going to be? And I'm going to tell you right now. The fraction in front of that is 2/3. Now the question is, how do we come up with that? How did I come up with that? Well, it goes through all these points right here, and you can use, I'll just say you can use any 2 points to come up with this 2/3. You should notice, if I go from this point here to this point here, I can't even read that 3. There are 3 spaces in between. If I go from this point here to this point here, also 3 spaces in between. There's a 3 there. Now where does the 2 come from? When you go up or down from there to there, how many spaces are you going? 2 spaces. And that's basically where that comes from. So this right here, that's where the line crosses the y-axis. So that's the crossing the y-axis. That top number tells you how far up and down it goes, we'll say, up/down. That number tells you how far left or right you go from point to point. So when you go from point to point, you would go up 2 and to the right 3. Or you could say you could go down 2 and to the left 3. Y equals 1/2 x minus 7. Where would that first point be located? When you look here, that says a -7, so we'll go to -7. There's my first point. Then how would I get to the next point? Yeah, that's a good question. I'll just say it'll be right by 2. You go up by 1, right by 2. 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 You only need to draw 2 points, but I just kept going to show you that I don't make a straight line there. So if I were to pick any number, I'm going to pick an even number. I'm going to pick the number 8 for x. Now if I replace it, half of 8 minus 7. What's half of 8? What's 4 minus 7? Negative 3. So when x is 8, y is going to equal to, let's see, there's 8. Oh, look at that. There it is, negative 3. Now the question that's asked is, how do we know it's going to the right, or how do we know it's even going up? When you have a graph that looks like this, let's say y equals 2x plus 3. If this is a positive number, that means it's going up. If it's a negative number, yes, it would be going down. Now if I had this, it was a negative 2, I would still start at the 3. But that means I go down 2 and to the right 1. So I go down 2 and to the right 1. So that one now it's pointing down. Get what I'm saying? Because it's negative. So it seems like the bigger number it is, the steeper it's going to get, which seems to make sense, right? So if it's a bigger number, it's going to get steeper and steeper. What happens if the line goes straight across this way? What does that mean? Well, say that again. It's a 0. So if this is positive and this is negative, straight across must be somewhere in between, which is 0, which makes sense because that means y is always going to equal to positive 3, which if you look at this line here, it's always equal to positive 3, isn't it? It's going straight across. So if they give you a problem like this, 5x plus 3y equals 7, your job is to make this look something like this, where it says y equals. How do I make this say y equals? We want to get the y by itself, don't we? So how do I get this by itself? Take away the 5x. So you got 3y equals, we'll say negative 5x plus 7. Then I do what? Then you divide everything by 3. So y equals negative 5 over 3 plus 7 over 3. So if I were to draw this, so I look at that, oh, I know what my line is going to do. It's going to go down because it's negative. I know, that's a good question. There it is. So now I can graph this. The line's going to cross at 7 over 3. What's 7 divided by 3? 3, 6, 2, and 1/3. So I go to 2 and 1/3, which is somewhere right about there. Then I go down 5 and to the right 3. 1, 2, 3, 4, 5. To the right 1, 2, 3.